Welcome everyone! This is the 15th chapter of the Crystal Clear Electronics video series. The 15th chapter will be divided into 3 video parts where we will learn about PWM. We encourage you to build all the circuits yourself. The PWM parts was written by Gábor Baracsi, professionally lectured by Szabolcs Veréb and Gergely Lagler. Today's presenter is Ambrus Zelei.
Thank you very much for the introduction to Péter Horváth, who will be my partner on this topic. Péter, I know you're a student at the Faculty of Electrical Engineering at the Budapest University of Technology and Economics. Please tell us a few words about yourself.
Thank you for the introduction. My personal item is the Rubik's Cube that earned me my first salary in elementary school, a hot dog from the kitchen lady. Hopefully, thanks to this video series, your paycheck will be bigger than that. So the topic we are going to cover is the widely used PWM, pulse width modulation. But what is PWM?
We will explain in this video. Beforehand, I feel it's too bright in the studio. Can you turn down the brightness a little bit?
Sure.
I think the lighting is too strong. But why are you turning it on and off? What's with the continuous switching?
Because I've revised my curriculum and I've prepared for PWM.
Are you telling me that by switching it up and down between full brightness and zero, we're going to have a good average brightness here?
Yes, that's right.
Well, that sounds crazy, but you're right. This is what PWM is really about, and we are going to explain that to you in a slightly more professional way so you can apply it to real-life electronics. To give you a chance to try it all out, we'll start by implementing a circuit. In a previous chapter, we learned about the NE555 integrated circuit and the A-stable circuit. In this chapter, we will talk about a similar circuit shown on the schematic. In addition to the 555 IC, we have another interesting three-legged component, the adjustable resistor, or potentiometer for short. Connect the components on a breadboard shown in the figure. Make sure that such ICs are always placed in such a way that there is no crossover between the two leg rows. So it should be placed in the middle of the breadboard.
The device is assembled and I think everything has been checked. We have assembled 2 circuits here, one for just this part, the other for the whole chapter. Here I suggest that you also stop the video and assemble the circuit.
When we are sure we have connected everything correctly, we power the system. We're using this 12-volt socket, but you can also use a laboratory power supply. When trying out the circuit, you can see that if you adjust the potentiometer PB, the brightness of the LED changes. By following this chapter of the curriculum, you will learn why we have solved what at first glance seems to be a very simple task with so many components, and you will learn about a very important control method called PWM.
My suggestion is to first examine what your circuit is doing exactly.
First, check the output of 555. To do this, as you can see, we've packed a laptop and a USB-connected oscilloscope. As you can see, this is a much smaller, more compact solution than the big box oscilloscope from the old days. It even has the bonus that the software you get with it calculates a lot of things in advance. So you don't have to do manual calculations like with an old oscilloscope, but everything is calculated digitally. For example, the frequency is calculated for us within seconds. However, it is not included in the component list that you can download from the Crystal Clear Electronics website. We have added this to a better illustration for today's material. If the potentiometer PB is adjusted during measurements, we can see either an increasing or decreasing duty cycle, while the frequency stays constant. The duty cycle is the ratio of on time and off time of the wave. The horizontal axis on the oscilloscope screen represents time, and the vertical axis shows the voltage. The duty cycle is the time ratio of the low-level signal to the high-level signal within a period. To illustrate this, I will set different duty cycles. You can set one so that the duty cycle is, for example, 70%. You'll see 70% of the time signal is almost at 12 volts, and the other 30% of the time it's around 0. Now I'm going to adjust the potentiometer to reduce the duty cycle. I'm trying to set it about 50-50%. Maybe I got it right this time. Do you agree?
Yes.
And if I adjust it further, what happens is that I can go down to 20% with the duty cycle. At this point, there is hardly any period when the signal is high, and instead, the voltage is typically at the 0 level.
So our circuit implements this level of pulse width modulation.
Yes. And that concludes the first video in the PWM topic. You've already done a lot of work on building the circuit. Play around with it to get to know it better.
In the next video, we will focus on the timing.
See you in the next video. Bye!
Bye!